So we've seen how to calculate the path length. The path length, even of a curved path, we view as being made up of a bunch of little straight line segments, and we add up the length of all of those line segments. And that's what this definite integral from calculus does. If this term happens to be a constant, then we have a much simpler version of the formula. The thing we're adding isn't changing as we're adding it up, so we can basically just multiply to get the path length. And what we'll see is that in that case, this is really the Pythagorean formula in slight disguise. So let's do a quick example. Suppose we want to know the distance between point A and point B. So this is space. Here's y, here's x. A is at 0, 0. B is at 3, 4. So for this case, dx dy is constant. As you move along this path, the size of your x step and the size of the y step, that ratio stays the same. And so that's really the same thing as saying that the slope is constant. So then, the path length, in this case, is 1 plus delta x over delta y squared, delta y. So since things are constant, I don't need to think about breaking things up into tiny little steps. We can just do the big steps all at once. So delta y, that's 4. That's how far it is from A to B in the y direction. That's the y coordinate difference. The x coordinate difference is 3. So let's plug in and see what we get. So this is 1 plus 3 squared over 4 squared square root times y, which is 4. So let's see. 3 squared is 9. 4 squared is 16. 1 plus 9 sixteenths over 4. And then, let's see, in order to add fractions, we're going to have to put this over a common denominator. So I can write 1 as 16 over 16. 16 over 16 plus 9 over 16. Aha, and now that I have 16 downstairs, I can add these up top. 9 plus 16 is 25. That's a nice number. 25 over 16 square root times 4. So good news, these are perfect squares. Square root of 25 is 5. Square root of 16 is 4. This is 5/4 times 4. Hey, the 4's cancel. That's great news. So we get 5. That's our answer. So you would get the same thing if you use a Pythagorean formula. 3 squared plus 4 squared is indeed 5 squared. So this is really Pythagoras, the distance formula, just in slight disguise. So we've seen in some detail, I suspect too much detail, how to think about the length of a curved path in space. What we'll do in the next couple of videos is repeat this analysis, building on this, but we'll be considering curved world lines in space-time.